There is an unseen power at work, a force that may even have launched the universe, creating pressure that is everywhere, causing space to expand. With no way to measure this force directly, and no real understanding of its mechanisms of transmission, astronomers simply call this ever-present influence dark energy.
We might imagine that once upon a time, in some possibly other universe, there was a concentration of this kind of energy that we'll call vacuum energy or the dark energy that created what became our universe, created the space that became our universe.
Dark energy and dark matter are two very different things. In fact, the two are at opposite ends of a cosmological game of tug-of-war. Dark matter works to slow the expansion of the universe, initiating a gravitational potential, triggering common, visible, baryonic matter to fall together. Dark matter is the pull behind everything. But dark energy is the push, and it is always one step ahead. Albert Einstein was onto this early. In his equations of general relativity, he introduced a cosmological constant, an expanding force to counteract the tug of gravity. He later discarded this notion, calling it the biggest blunder of his career. But the universe agrees with young Einstein after all. By constantly conjuring up new space, dark energy is literally ripping open the fabric of the universe and stitching more material in between.
Wow, what is being indicated here is that the universe must have had an initial expansion period, must have been slowing down because of the dark matter, but now the second stage has kicked in here and we're actually accelerating again. So it's started up, slowed down, and now it's accelerating. And now we see a universe that's not only expanding, but it's expanding faster and faster and faster. It's flying apart.
Astronomers know this from watching Type 1a supernova stars in faraway galaxies. Type 1a's glow with a certain known brightness.
It is a very precise explosion in terms of its luminosity. And so not only can we see these things across at the very distant parts of the universe, but we know how bright it is because of this mechanism which is so precise. So we know how bright it is as it goes off at 5-6 billion light years away. We know how bright it is and we can measure its distance.
And if that distance is so great that the expansion of space out there is approaching the speed of light, it is possible to use the 1A supernova's luster to calibrate the fundamental fate of the universe. Astronomers are left looking at three possibilities. 1. That the universe began in a Big Bang and has been coasting ever since, with no exotic dark matter nor quixotic dark energy helping nor hindering. Or 2. That the Big Bang's expansion is being counteracted by a large enough quantity of dark matter to cause the universe to slow, and eventually to collapse. Or 3. That there is enough dark energy at work to overcome the bulk of dark matter that must be lurking around in the halos of the galaxies. Only this third possibility fits the Type 1a supernova observations. But the kicker is this. If this model is correct, the cosmos is not only expanding, it must be inflating at an ever faster and faster rate.
And in the tug-of-war then between the dark matter pulling things together and the dark energy pulling things apart, the dark energy is now winning.
Your universe has shifted into high gear on a one-way trip to oblivion. Or perhaps not. As proven by the first atomic bombs, matter and energy can be spectacularly converted into one another. It was dark energy that kicked off the creation of the universe, then dramatically transformed itself into ordinary matter. Maybe the magic will repeat.